All right, guys, thanks for being on Thursday, February 4th. We are going to continue where we left off, which is lesson 4-2. So if you have a workbook at home, I would recommend that you follow along with the workbook in lesson 4-2. We are talking about writing equations and expressions. We started talking about that on Tuesday, and we are going to continue talking about that today. So we've got the video ready to go. Let's do it.
What are equivalent expressions? Think about this question during the lesson. The Student Council has spent $300 on supplies needed to sponsor a dance concert fundraiser. 3 council members wrote these expressions to represent the total amount raised for T tickets sold. 6 times T minus 300. 6 times the quantity, T minus 50, and negative 300 plus 6 times T. Can they all be correct? How can you use the properties of operations to determine whether the expressions are equivalent? Let's begin by verifying that the first expression represents the amount raised for T tickets sold.
All right. So let's go back and look at the question it's asking us here real quick, just so we're clear on what information we need to know. The Student Council has spent $300 on supplies. And then they're going to sell tickets. That's for $6 a ticket, right? You see the ticket here. Each person, the ticket is $6, okay? So they're going to make $6 for every person that comes, and they spent $300 on buying all the stuff, right? They needed to buy decorations and food and drinks and blah, 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 okay? So let's go back to where we were. All right. So we're looking at this first one. 6t, which is 6 times t, right? We know that two things that are next to each other that don't have a sign in the middle, we know that that is multiplying. So 6 times t. T would be the number of tickets that they sell, right? 6 times t. If they sell 1 ticket, 6 times 1, they get $6, right? If they sell 100 tickets, 6 times 100 would be $600. So that seems to be correct when it comes to the amount of money they're going to take in from selling tickets, right? They get $6 for each ticket, $6 per ticket, and we're going to multiply that by the number of tickets. Right? If they sell, if I said, if they sold 100 tickets, if 100 people came, they would make $600, right? So that is correct. Now, this minus 300 is the cost of supplies, right? Whatever they make, they have to subtract 300 to pay back the people who bought the supplies, right? Some of the people on the committee, typically when you organize something like this, when you organize a fundraiser or an event or whatever, the people that buy stuff will keep their receipts for what they bought, right? And then at the end of the event, the people that bought the drinks and the food and the decorations and whatever else, they get reimbursed, right? They get paid back, which is reimbursed is another way of saying they get paid back for what they spent. So whatever they make for tickets, let's say it's 100 people come, so they make $600. They have to subtract 300 for the cost of their supplies. And that's how much money they would profit. Okay, so this seems to be a good equation. This seems to be a good expression for the amount of money they're going to make. Let's go to the next one.
Does this expression represent the amount raised from ticket sales?
Yes, it does. We just said that yes, it does represent the amount raised, right? 6 times T is the amount from ticket sales, and then minus 300 is the cost, right? So let's go to the next one.
The expression subtracts the cost of supplies, $300. Total amount raised. It does represent the amount raised from ticket sales. You can use properties of operations to write expressions that are equivalent to other expressions. What property can you use to remove the parentheses from this expression?
Select your answer.
Sorry, guys, I'm getting with a student that's testing. All right. This right here is asking us about the parentheses, okay? So, do we call this the commutative property, the associative property, or the distributive property? You may not know this, okay, because I don't think we've talked about parentheses yet, but you may have learned it in 6th grade. The parentheses right here are distribution, okay? This is the distributive property. So 6 gets distributed to the t, and 6 gets distributed to the negative 50, okay? So 6 times t, which is what we had here, and then 6 times 50 is 300. So we'd have minus 300, okay? So this is distributive property, and it looks like this would be correct. I'm not sure why you would do it like this, because there's no reason to split up the $300 into 6 groups of 50, but this does technically give us the correct answer with distributive property.
Use the distributive property to remove the parentheses. 6 times t minus 6 times 50, which simplifies to 6 times t minus 300. 6 times the quantity, t minus 50, and 6 times t minus 300 are equivalent expressions. What property of operations can you use to rewrite negative 300 plus 6 times t so that you can compare it to the other two expressions?
What property of operations can be used to rewrite negative 300 plus 6t? Let's talk about this. This is the same thing, right, as this. It's just in reverse order. And we know that order doesn't really matter when we are adding or subtracting something, right? We have negative 300 in both, and we have positive 6t in both. So it doesn't matter what order we put them in. Order does not matter when we're adding things, right? So as long as we keep our signs the same, right? The negative stays with the 300 and the positive stays with the 6t. So these are the same thing, just written in 2 different ways.
The commutative property, which says a plus b is equal to b plus a, allows us to change the order of terms. Negative 300 plus 6 times t is equal to 6 times t plus negative 300. And adding a negative number is the same as subtracting its opposite. 6.
So you can see why these are the same, right? We call that the commutative property. The order of things does not matter if we are adding them, right? The same thing as the order does not matter if we're multiplying either, right? 4 times 6 is the same as 6 times 4. We know that, but we also know that 4 plus 6 is the same as 6 plus 4. Commutative property says a plus b equals b plus a. It doesn't matter what order you add things. As long as you add them all up, you're going to get the same answer, right? And so that's what they're showing us here, that this and this are exactly the same thing. They have the same 2 values, just added in different orders. That's the commutative property.
6 times t minus 300, 6 times the quantity, t minus 50, and negative 300 plus 6 times t are all equivalent expressions. The council members wrote equivalent expressions. They are all correct. Now you've seen how properties of operations can help you figure out whether expressions are equivalent.
All right. So we have talked about the distributive property, which is these parentheses. The 6 would again get multiplied. Let me put this on the Jamboard. I'm going to do the commutative or the distributive property real quick. We have a parentheses here. Oh. And we have t minus 50. Okay. What happens here is this gets multiplied by both things inside. It gets multiplied by t and it gets multiplied by 50. We know that 6 times t would be 6t. And we know that 6 times 50 would be 300. And we obviously keep our minus sign, right? So that's how that works. The distributive property is 6t. 6 times t is 6t. And 6 times 50 is 300. So that's how they got what they got in the middle, in this middle expression. All right. Now it's going to ask us to do one. Nancy wrote the expression 3x minus 12 to represent the relationship in a table of values. Use the properties of operations to write two equivalent expressions. All right, so the first one it's going to ask us to distribute, or really the opposite of distribute. We're going to pull out the 3, okay? So if we're going to pull out the 3 and put it outside parentheses, we really divided, right? We had 3x, and we divided this by 3 to pull it out outside. So if we divided that by 3, let's divide 12 by 3. That's going to give us what goes inside. Well, 12 divided by 3 is 4, right? 4 times 3 is 12. 12 divided by 3 is 4. So this is going to be a 4, right? So let's see if this works. Let's distribute. 3 times x is 3x. 3 times 4 is 12. And we keep our sign, right? So it works, right? That's what we have here, and that's what we have here. So we're good. All right. Now, we want us to write with commutative property. It just wants us to write it backwards. So instead of writing 3x minus 12, we're going to write minus 12 plus 3x. Oh, wait a minute. It's asking us something different. I didn't read the instructions. I'm dumb. What property can you use to write an equivalent expression for this? We could also write this as negative 12 plus 3x. All right, let's go down to the bottom now. All right, let's distribute this. It wants us to distribute, so negative 5 times x and negative 5 times negative 2. Now, negative 5 times x is negative 5x. Negative 5 times negative 2. A negative times a negative is a positive. All right, so that's what we got. Or we could write it as 10 minus 5x. Oh, this was for this. Yeah. So this was supposed to be here. That's what I thought. All right. So for this one, we wrote a couple of equivalent expressions here using distribution. All right. We good on this on distribution? Any questions about distribution? The commutative property should be something we already know. We know that no matter what we add, as long as we add them all together, it doesn't matter what order it is. 1 plus 2 is 3. 2 plus 1 is 3. It does not matter what order they come in, right? That is the commutative property. Distributive property is a little bit trickier, and it's a little bit more difficult to master. So that's what we're doing here. All right, I think it's going to give us a couple more examples. Actually, you know what? Let's just do a couple more examples on the Jamboard. Why don't we do that? Let's make and let's put, I don't know, 2. Let's distribute these. Oh, I'm going to redraw that. We are multiplying the 3 times 4x, and we are multiplying the 3 times 3. 3 times 4x equal, 3 times 4 is 12. So this is going to be 12x, right? Because we have to reattach our x. 3 times 4 is 12, so we get 12x. Now 3 times negative 3. 3 times 3 is 9, so 3 times negative 3 is negative 9, okay? Let's do it down here. Let's distribute. I'll use green. 2 times 8 and 2 times positive 1. 2 times 8x is 16x, right? Because 2 times 8 is 16, and then we have to reattach our x, right? 2 times 8x is 16x, and 2 times positive 1 is positive 2. So, to distribute these two expressions into standard form, that's all we do. This expression is equal to 12x minus 9, and this expression is equal to 16x plus 2. All right, so there's a couple more examples of distribution. Is everybody with me? Does anybody have questions? Preguntas. Tenemos preguntas. Tengo respuestas. Does anyone have questions? I have responses or answers. Nobody. All right, let's keep going. I just got somebody in the chat. Okay, no. All right, cool. Glad you're with me. All right, so this makes sense. I'm glad. Let's go on to the next problem in Savas. Example number 2. Combining like terms. This should be interesting. Let's look at some combining like terms.
Write equivalent expressions by combining like terms. Part A, negative 5x plus 2y plus 3x. To begin, write the original
Okay, I'll just let them do it.
expression. Next, use the commutative property to rearrange the expression so that like terms are together.
All right, do you see what they did? We know that the commutative property says that no matter what order we go in, adding and subtracting is all going to be the same, right? As long as we keep the signs. Adding is always going to be the same no matter what order. So they switched this 2y and this 3x so that the x's could be next to each other, because that makes it easier for us to visualize. If you can do it in your head without doing that, then you can do it in your head. Personally, I just like to look at, I know I have a negative 5x and a plus 3x. The x's are what we call like terms. They are both coefficients of x. So they're both x with a coefficient attached, I should say. But we know that if we have x's and x's, we are just going to add or subtract them together, right? We have negative 5 and then we add 3. If we were on a number line, we would go 3 spots to the right, so we would end up at negative 2. All right, we are combining the two x's into one term. We have to combine like terms.
Use the distributive property to combine like terms. Negative 5x plus 3x is equal to the quantity negative 5 plus 3 times x. The last step is to simplify negative 5 plus 3, which is equal to negative 2. Look for relationships.
All right, they did it in slightly a different way than I would do it, but that way works too, right? I personally like to just look at that and I can think negative 5x plus 3x. So what's negative 5 plus 3? Well, it's negative 2. I can just go to a number line. If I can't figure it out, I could go to a number line and, you know, I'd make a number line and here's 0, negative 1, negative 2, negative 3, negative 4, negative 5. And then I could just go to my starting point at negative 5 and I could go, okay, well, now we're going to go 3 spots to the right, plus 3, right? 1, 2, 3. Well, I end up at negative 2, right? We know that. That's how I do it. I just look at that and I think, okay, negative 5 plus 3 is negative 2. You can also break it down and separate the x by distributive property. I think that's a harder and unnecessarily hard way to do this, but you can do it that way if that helps you. Personally, it doesn't help me much. I just look at, hey, what's -5 plus 3? Well, we know these expressions are equivalent because we just proved it, right? -5 plus 3 is -2. So we have a total of -2x when we combine these like terms. So this and this are equivalent. And this is more correct because it's simplified. All the terms that we can combine are combined. A lot of things in that one. That was a tricky one. Okay. But really, this is a distributive property here, but this is a plus sign, so it really doesn't change anything. If this was a minus sign, we would have to distribute the minus to the 1/6 x and to the y, right? They would both become negative. But it's a plus sign, so really all we needed to do here was combine our like terms. That's what they're getting at, right? 1/3 x and 1/6 x need to be combined. In order to do that, in order for us to add them, we have to have common denominators, which you guys learned about in elementary school, right? When we were adding fractions. So they made 1/3 into sixths by multiplying the top and bottom by 2. 2/6 plus 1/6 is 3/6. And then we had to reduce 3/6 down to 1/2, right? Because both of these have a common factor of 3. So we divide the top and bottom by 3 and reduce it to get our final answer. Oh, I wasn't sharing the tab. Oh, goodness. Here, let me go back and... Sorry, guys.
Equivalent expression for part B. 1/3 x plus the quantity 1/6 x plus y. Write the original expression. Next, use the associative property to change the order of the addition. Find the common...
Right. We know we have to combine these. 1/3 x and 1/6 x. They're like terms. So they put them next to each other. They find the common denominator
for the two
6.
fractions. Write 1/3 as 2/6. Use the distributive property to combine like terms.
2/6 plus 1/6 is 3/6. And then reduce.
The last step is to reduce the fraction to simplest terms. The expression is 1/2 x plus y. Notice that the original expression has 3 terms, and it simplifies to an equivalent expression with 2 terms.
All right. Sorry for not sharing the screen the first time. Hopefully you guys got it. All right. Let's go try one of our own here. We have an expression here with a parentheses here. Use the properties of operations to write 2 expressions that are equivalent to this expression. 3/4 n plus 8 plus the quantity 8 plus 1/3 z. Well, what we can do here, I need my pen. There it is. It's asking us to write some equivalent expressions here. We have parentheses. Technically, we would have to distribute this plus sign, but it's a plus sign, so it doesn't change anything. So really, we can rewrite this without the parentheses. Right? Or we could rewrite this with the letters next to each other. They're not like terms. One's a Z and one's an N. But if it helps us visualize this, we can change the order, right? Because the commutative property says we can change the order of things we're adding. So we could write it as 3/4 n plus 1/3 z plus 8, right? We just switched the order here. We can do that. We can switch the order if we're adding things. We cannot switch the order if we are dividing, and we can't switch the order if we're subtracting. But if you're adding or multiplying, we can always switch the order. So, everybody with me? All we did there was just rewrite this in two different ways. We rewrote it without the parentheses because the plus sign, doesn't really matter because it doesn't change anything. Again, if this was a minus, then this would become -8 and minus 1/3 z because the minus sign would distribute, but that's not what we had. So that one's kind of an easy question. Just asking us to rewrite it in different ways. All right, let's go to the next example. Which of the expressions below are equivalent to -2/3 x minus 2? -2/3 x minus 2. Okay, so let's look at this. We have a -2/3 x and a plus -2. Well, adding a negative is the same as subtraction. So adding a -2 is the same as minus. So that's going to be equivalent. We look at this one. We have a -2/3 x, right? -2/3 x, but this is a positive 2. There's no negative sign. We have a negative sign with this 2. This one is a positive 2, so that's not equivalent. Not the same. Okay? Well, let's look at this one. This has got a bunch of crazy stuff. Negative x plus 1/3 x plus -2. All right, so we got to combine the like terms here. We have -x and we add 1/3 x. So we have -2/3 x, right? We have a -x one spot to the left of 0 on the number line, and we get 1/3 of a spot back. We are still at -2/3 x, right? And then we have a -2 there, a plus -2. So this one's going to be equivalent. There we go. That one is tricky, but we had to combine like terms. And combining like terms can be difficult when we start to deal with negatives and fractions and all this stuff. But if we combine these, we get -2/3 x, which is what we have up here in the original expression. And that's just going to explain exactly what I just explained. So let's skip this. Okay. This one does show you how they combine their like terms, right? -x plus 1/3 x gave us -2/3 x, right? So this is equivalent. And the middle one was not, just like we figured out. Write two equivalent expressions. Write two expressions that are equivalent to this expression. -5/4 x plus 3/4. Well, one we could do is we could take out the fourths from both of these by doing this. What if I did this? If I want to take out the divide by 4 and the divide by 4, I could do this. 1/4 times -5x minus 3. I could do that, right? Because look what happens. All right, hold on, give me 1 second. Okay. Sorry, I just had a kid that's testing ask me a question. Does everybody see what I did here? I separated the divide by fours, the fourths out, and I made them distributive. So 1/4 times 5x is 5 over 4x. 1/4 times 3 is 3 over 4, right? So that's one way I could do this. Let's think of another way we could distribute this. I could Sorry, guys, I'm just dealing with testing. Give me one more minute here. All right, a couple seconds from now, you ought to be good to go. I just confirmed you. But thanks for letting me know that you needed to pause. And now we're ready to roll. So welcome back. All right, guys, sorry about that. All right, we're looking at a second way to write this. Not sure why we would write this in any other way than distributive property. I mean, I guess we could use commutative property and just rewrite it backwards. We could start out with -3/4 minus 5/4 x, right? We just switched the order here. We can do that because that's commutative property. As long as we keep the signs the same. In this case, they're both negative, so that makes it easy. As long as we keep the signs with the original numbers, we can switch the order of them, right? So that's another way we could write an equivalent expression, right? Just flip them around. We can switch the order. Or we could distribute. We could draw out the divide by fours from both of these numbers. All right. Additional example. Ileana wrote the expression 30 minus 10q to represent the relationship in a table of values. Use properties of operation to write equivalent expressions. All right, so 30 minus 10q. So what we could do, the first thing we could do is separate 10 out. Because 10 divided by 10 is 1, 30 is divisible by 10 as well. 30 divided by 10 is 3. So we go to the Jamboard. We could separate 10 out, right? So I'm dividing by 10, dividing by 10. That's going to separate it. 30 divided by 10 is 3. 10 divided by 10 is 1. So we get that. That's an equivalent expression because 10 times 3 is 30, and 10 times -q is -10q, which is what we have, right? So that's an equivalent expression right there. We could also just write this backwards. We could start out with -10q plus 30. you could write it the other way, right? We know that we can always rearrange the order of things and rewrite it backwards if we want to, as long as we keep the signs. Notice that the negative sign stayed with the 10 and the 30 stayed as positive 30, right? As long as we keep our signs straight and keep our signs with what they originally were with, we can rearrange things. All right, so they did 4 of them here, or they did 3. They did what I did. They drew out the 10 by dividing. They rearranged. They also switched the signs here. Oh, they also rearranged inside the parentheses. So you could do it that way too, right? They took this, 3 minus q, and they rewrote it as minus q plus 3, or negative q plus 3, okay? Let's try another one. Latana wrote the expression 28 minus 4f to represent the relationship in a table of values. 28 minus 4f. Let's go over to the Jamboard. Well, 28 is divisible by 4. So we could divide both these by 4. So that would be, the 4 goes outside. And then it would leave us 28 divided by 4 is 7, minus 4 divided by 4 is 1. So we just have f, right? So that works, because 4 times 7 is 28, and 4 times negative f is negative 4f, right? Again, we could also write this backwards. We could write negative 4f plus 28, because again, the negative has to stay with the 4, and the 28 was positive, so it stays positive, right? Or we could rewrite this with the parentheses and make it backwards. 4 negative f plus 7, right? The negative f goes here, and the 7 went here, and stayed positive. Again, it's just getting you guys used to different ways to write the same information, because we don't necessarily always want to write information different ways, but we have to be able to look at information that's presented in different ways and be able to make sense of it, right? So we have to be able to, if they say true or false, and they say 28 minus 4f equals 4 times 7 minus f, and it's a true or false, we would need to know that this is true, because you would look at the distribution. 4 times 7 is 28, and 4 times f is 4f, and we have a minus sign, so it's negative 4f. So we know that these are equal. That's true, right? And there's all kinds of applications where we would need to know that this right here is a true statement, right? There are 2 different ways of writing the same thing. Oh. Okay. Let's keep on keeping on. Let me go back to Devos. And we'll do one more here, because we have one more problem on the topic. It's asking us to write some equivalent expressions here. Write equivalent expressions for each expression. All right, we get m plus 4n minus 2.5m. Let's clear this. And the second one is 1/8 y plus 6y minus 5x. All right. So what we need to do here is just combine like terms. So I'm going to circle them in red, or underline them in red. We have m's and m's. We have 2 different m's, and they need to be combined. Okay? So I'm going to combine them. I have a positive m, and then I'm subtracting 2.5. So I'm going to get negative 1.5m. because this is 1m, right? If I have 1 and I subtract 2.5, I'm going to get negative 1.5. And that's just plus 4n. All right, same thing here. I've got y's that need to be combined. 1/8 and 6. Well, 6 plus 1/8 is simply 6 and 1/8. Y minus 5x, okay? I combined like terms. I had m's and m's, and I combined them. I had y's and y's. Whoop, I didn't want to use blue in there. I had y's and y's, and I combined them. All we did was just add the coefficients. We want to combine two like terms. All we have to do is add the coefficients. That's it. Or subtract if one of them is negative. Okay, let's see if we're right. Let's go back to Savas and see if we're right. All right, so they rewrote it so that the m's were next to each other, right? Negative 2.5m plus 1m is negative 1.5m plus 4n. All right, they combined like terms here as well. You got 1/8 y and 6y. You just add them together. 1/8 plus 6 is 6 and 1/8. And you tack on the minus 5x. Easy. All right, well, that wraps it up. So that is the lesson. Would you like me to do any additional problems? Would you like me to review anything? Do you have any questions? All right. I have one no. I don't know if you guys can hear that. My daughter is shouting, "Dad, Mom." She just woke up. So she's screaming to get me out of bed. Let me out of here. Dad, Mom. Okay. Well, if nobody has any questions, I'm going to go get my kiddo out of bed. Can you hear her now? All right. I'm going to stop the recording. We're done with the lesson. So I'm going to go get my kiddo out of bed. I'll be here on the meet. If you guys have questions, but I'm going to go get Josie out of bed. All right. Thanks for being here. Good lesson. And I will see you guys. Well, I'll see you. Some of you I'll see later today. Some of you I'll see tomorrow.